Welcome back to lecture. In this lesson, I would like to talk about scientific notation and how to put a number into the standard form or scientific notation. So scientific notation, also called standard form, is a special way of writing numbers. What I would like to do is to write a number as a power of 10, as a multiple of a power of 10, and then store or maintain the significant digits. Here the significant digit is 7. And the other two, the zeros, are just powers of 10. It's just like multiplying 7 times 100. But I want to write it as a power of 10, not as a power of 100. 10 squared is 100. So I'm going to convert this by taking, here's the decimal where it is now. It's understood to be at the very end. I'm going to move it 2 places to the left to get it there to maintain the 7.0 significant. That gives us 7 times 10 squared in scientific notation. Here's this, a very large number, and what we're going to do is take, here's the decimal place here. I would like to maintain the significant digits, and I want the decimal place right there past that first number, so 4.9 is where I would like it. And then the rest of it, I'm going to count the number of times I would have to multiply by 10. So here would be 3 times, 6 times, 7, 8, 9 times. So this is 4.9 times 10 to the 9. So each time I would multiply by 10, I would move the decimal place 1 time to the right, and that would give us this number right here. So it makes it easy to use big and small values. Right now we've talked about bigs, but it works as well in the small values. So why is 700 written as 7 times 10 squared in scientific notation? The 700 is 7 times 100. And then the 100 is 10 squared, okay? So 700 is just 7 times 10 squared. They both have the same value, the 700 and the 7 times 10 squared. They're just shown in different ways. They're equivalent forms. So how do we convert? Again, we move the decimal point so that it is between the first 2 significant digits. I want to maintain the significant digits here. 0 is not really significant, so I can encode them as a power of 10, and we'll be able to maintain this. Okay. So what is significant versus non-significant? Significant values are anything other than 0. 0 is a non-significant value. We can just put that as a power of 10, and we can recover the 0. Moving right versus left, if you move the decimal place to the right, your exponent is negative. So for very small numbers, we're going to have to move it to the right to get it between the first 2 significant digits. And then if it's a larger than 1, then we'd have to move it to the left. So here's our examples. We're going to convert the following numbers into scientific notation. The point 004694, the 4.694, that 4 point, that's going to be where we're going to need the decimal. So that's going to be 3 places to the right that I need to move my decimal point to get it between the first 2 significant digits. So I'm going to write, each time I move it to the right, I count that as a 10 to the negative 1. So I'm dividing by 10. 10 to the negative 1 is just 1/10. So that's 1, 2, 3. So it would be 4.694 times 10 to the negative 3rd. The 1.98, that's really times 10 to the 0. 10 to the 0 is just 1. So if I wanted it as a product of 10, it would be times 10 to the 0. The significant digits is between that 1 and the 9. 4,679,000. I want it right there. Between the 4 and the 6 is my significant digits are 4679. So I want 4.679. And how many times would I have to move it over? 1, 2, 3, 4, 5, 6. So that would be times 10 to the 6. Okay. So that's that kind of sums up scientific notation, powers of 10. Take a look at your text, and we'll see you next time.